which I know we left off talking about normal lines, yes? Or getting ready to. Let me rephrase
We
that.
left off.
We had not talked about normal lines yet, but okay, so lesson 2.1. We are picking up where we were, rates of change and the tangent line problem. And we talked about tangent being a tangent line being a line that just touches at one point, right? Whereas a secant line crosses through, touches at two, right? Okay. And then, so the slope of the curve at that tangent point is what we're learning about, which is going to be our derivative here eventually. Okay, so new vocabulary. Is this new vocabulary or was it in pre-calc? I think this is calculus vocabulary only. So normal line. You have been working with normal lines since Algebra 1. You just haven't called them normal lines. Okay, so it's just a vocabulary here. The normal line to a curve at a point is the line perpendicular. So when we talk about a normal line, normal is another word for perpendicular. I don't know. That might be, if you Google the definition, that might not come up exactly, but for our mathematical purposes, when we talk about a normal line, we're looking for a perpendicular. So normal line is a line perpendicular to a curve at the point to the tangent line. To find the slope of the normal line, use the opposite reciprocal of the slope of the tangent line. Okay, so what we're looking at here, slope of the tangent line. Okay, that's our definition of derivative that we haven't officially used the word derivative, but that's where we're going with it. We were using, what were we calling it? The difference quotient, I guess, or slope of a curve at a point. Okay, we have that definition to find slope of a curve at a point, so we can find the slope of the tangent line here. Once we know the slope of the tangent line, well, the normal line is a perpendicular line, and perpendicular lines have slopes that are opposite reciprocals. So let's look at example 6. Use the limit definition to compute the slope of the tangent line at x equals a. Now, I can't arrow back because I know I deleted the pages, but if you look back when it says the limit definition, we're using the limit definition on page 83. Okay, the limit is h approaches 0 of f of a plus h minus f of a all over h. That is our limit definition of slope. And that's what we're going to be doing here. Okay. And so, maybe we should do a side note here. I don't know. I'll side note it. We're going to have to know f of a plus h, and we're going to have to know f of a to fill in our definition. You want to start easy? What's f of a?
1 over a plus 3.
Good. Every place you've seen x, you replace it with a, right? So f of a is 1 over a plus 3. What's f of a plus h?
1 over a plus h plus 3.
Yes? Instead of 1 over x plus 3, it's 1 over a plus h plus 3. Are we good here? Okay, and then if you haven't flipped back, the definition we're using is the limit as h approaches 0 of f of a plus h minus f of a all over h. That's the limit definition they're talking about. So f of a plus h is going to be 1 over a plus h plus 3 minus f of a. So 1 over a plus 3, all divided by h. Now, I just did a big boo-boo. What did I not write before that? The limit. So figure out a way that you want to squeeze that in. For me, it's going to be I erased my m equals, and I'm going to scoot that over, and limit as h approaches 0. And that's a big calculus boo-boo because you don't put that limit notation in, it totally changes what we're doing here. So it is a big calculus boo-boo. May not seem like it to you guys, but you'll find out when I take points off of you for not writing limit notation when you need it. So, okay, now we have to be able to find this limit. And right now, it's kind of a known thing. If I put h equals 0 in right now, just plug the value in, it's 0 over 0. Because you're going to end up with 1 over a plus 3 minus 1 over a plus 3. So that's going to be something minus itself. So 0 over 0. So we have to manipulate this. We have to work with it so that it won't be 0 over 0. That numerator is an issue, isn't it?
Mm-hmm.
It's an ugly issue. It's two fractions being subtracted. Could we make those into one fraction?
You have to find the common denominator.
Okay. Common denominator is going to be
A plus H plus 3.
times
A plus H. Or A plus 3.
a plus 3. It's going to be the two denominators multiplied together. Okay, so let's see. The limit as h approaches 0. So denominator, I'm just worrying about the numerator right now, okay? Is going to be the a plus h plus 3 times a plus 3, correct? Now, can you do the numerator? What's my first fraction missing?
A plus 3.
It was missing a plus 3 the denominator, so you multiply the denominator by a plus 3 and numerator. 1 times a plus 3 is going to be
A plus
a plus 3. Minus, because we are subtracting here, correct? What's my second fraction missing in the denominator?
A plus H plus 3.
And so multiply it by a plus h plus 3, multiply the numerator by a plus h plus 3, which just multiplying by 1 is itself, right? Now I'm going to say minus, so I'm going to say minus the quantity a plus h plus 3. You see how I did that? When I said minus the quantity, I put it in parentheses because we're subtracting that whole value, right?
No.
Now, hold on before we do anything else here. It was this numerator, which just became one bigger fraction, right? And it was dividing by h.
Exactly.
Dividing by h is the same as
Multiplying by 1 over H.
multiplying by 1 over h. You see that? Dividing by one item is the same as multiplying by the reciprocal. Reciprocal of h is 1 over h. Very basic algebra rule, however, in the middle of a tough calculus problem, may not appear it. Okay, now I am willing to listen to you guys tell me how to clean this up because you guys were all doing it and I stopped you.
I don't know. Do I just cancel out?
What happens on top?
A's cancel and 3's.
Becomes a minus a, it becomes 3 minus 3, and what remains on top?
Negative H.
So this is going to be a. I'm subtracting everything in parentheses, minus a.
Yeah.
It's going to be 3 minus like term of 3, and we just have a
Negative.
negative h. Are you there, Sophie?
Yes, I got that.
Okay. Denominator is going to stay a plus h plus 3 times a plus 3. And then we still have times a 1 over h. However, what do you notice?
You can cancel out the H's.
H's cancel. Now, officially, we do have a
Negative.
negative left on top that may or may not matter in the end. And then what happens as we go to take the limit?
Still 0 in the denominator.
But
Mhm.
it's no longer.
Oh, never mind.
Okay, if you're taking the limit as h approaches 0, that means we're going to take 0 and
Plug in H.
plug it in for h, right?
I don't mind. I was thinking.
And so the only h I have left is that one right there, yes?
Mm-hmm.
So if I actually take this limit, okay, these h's were gone, so what's that mean is left on top?
Negative 1.
Negative 1. In the denominator, if that h goes to 0, what's left in my denominator?
A plus 3 squared.
And a plus 3 times a plus 3 can be written as a plus 3 quantity squared. Okay, we wanted the slope. So right there is my slope. Okay. Questions on my slope? I'm going to get rid of this arrow and put an equal sign because I'm afraid it looks like, well, maybe I'm getting rid of it. Geesh. I don't want it to look like it's pointing at just the denominator or something, which it kind of looked like for a moment. Okay. Not fun math, but did you follow?
Yes.
Okay. That was part A. What's part B ask us to do?
Find the slope of the curve at x equals -1.
Okay. How do we find the slope of the curve when x equals -1?
But -1 import A.
Yeah.
We already have a slope.
So negative.
Right. So, and that's here, this was the slope of the line at x equals A, yes?
Yeah.
So, generally speaking, what's my slope then? Generally speaking, -1 over,
X. Oh, okay.
because this was at x equals A. So, my general slope for this problem is this. Okay? So then, B is asking me to find the slope of the curve when x equals -1. So I'm going to do -1 over
-1 plus 3 times
-1 plus 3 quantity squared. Are we good with that?
And we can leave it like that. We don't have to distribute it.
Technically, you could leave it like this, but I would recommend you do some basic cleanup because I'm going to use this value in other upcoming pieces. What do you know about -1 plus 3?
That's 2.
And what do you know about 2 squared?
4.
So my opinion, well, technically, yes, you can leave it. My opinion is that you clean it up because we're getting ready to use this. Okay, so that's the slope of the curve at x equals -1. Part C, write the equation of the tangent line to the curve at x equals -1. Well, what part of a point do we know?
We know the slope. The slope.
We know the slope is -1/4. And what do we know about the point?
-1/4.
We're doing this at x equals -1, correct?
Yeah.
So,
Use point slope.
well, not yet. I still am missing a value. How could I find that other value?
Well, you have to
Use x.
If we know the x value is -1, how can we find the corresponding y value?
plug it into f of n.
Can we just plug it into the original problem?
It's pretty much saying y equals.
Yeah, f of x is the same as saying y equals. So if you find f of -1, that is 1 over, is it x plus 3? So -1 plus 3. Sorry, I'm on 2 different screens and it's messing me up. So it's going to be 1/2. So the ordered pair we're using is
-1.
-1 comma 1/2. The slope I'm using is -1/4. They asked me to write the equation of the tangent line. So, how do we write this?
Y equals -1/4
X plus 1
x plus 1.
plus 1/2.
Yep.
9 plus 1/2? Yeah, because it's y minus, yeah.
I was having to process the same thing, actually. I wasn't ready to answer that question. Okay, so we use the kind of adapted point slope form, yes? Okay. You could still technically have said y minus 1/2 equals -1/4 times x plus 1. That's okay as well. There's nothing that says you have to do this. There are just certain advantages to it. Okay, you good with that one? That's the equation of the tangent line. Okay, D. Write the equation of the normal normal line to the curve at x equals -1?
Isn't just force slope? Isn't it
Like y equals mx type of thing?
Well, so what do we know about normal?
It's perpendicular.
That's the same idea as saying perpendicular. And what do we know about perpendicular slopes?
Slopes
It's the opposite.
Reciprocal.
Reciprocal.
Opposite reciprocal. So the opposite of negative is positive. The reciprocal of 1/4 is? What point should I use?
It's the same one.
Yeah, -1.
Yeah, it's at x equals -1, but is that going to change the ordered pair?
No.
No, it's the same graph. So this is going to be -1, 1/2. Okay, so you got your answer?
Y equals 4x plus 1 plus 1.
4 times the quantity, x plus 1 plus 1/2. That really is going back to Algebra 1, isn't it, guys?
Yeah.
I mean, seriously there. And I guess I should say this is my, I'm going to say norm, m sub norm there for my normal slope. Okay. Ready for E?
So whenever it's telling you to put it into the x, like, or find the value of x equals -1.1, is that just putting it in as x?
Okay, hold on.
Oh, sorry.
I thought you were asking a question about the other
No,
part.
I'm asking a question about
So, okay, so E asks us to use the equation from C. Okay, so we have an equation from C to estimate the value of x equals -1.1. So to estimate that value, yes, you are just putting in the -1.1 into our equation there. Now, we're going to go back and use the tangent line equation, yes? Not normal line, we're going to use the tangent line. So we're going to use our answer from part C to do this. Okay. I'm trying to think. And I'll figure it out as I go here. So if we're trying to find f of -1.1, as I said, we're using this answer from C. So now, -1.1 is a decimal. So we can change it all and think decimals, or we can think fractions. I'm not sure which is better here. But you could say -0.25 times x plus 1. So -1.1 plus 1 plus 0.5. There's a little bit more that we're going to talk about besides just estimating here. Okay, well, think logically here, guys. -1.1 plus 1. Okay, 0.1 times the -0.25. Oh, wait, this is, did you guys say -0.1?
It is -1.1.
I don't know if you guys said it or not.
They said 2.1.
No, we didn't. I didn't say 2.1.
Someone said.
I don't even know what I said at this point, so, okay. Okay, reset. Okay, use your brains. -1.1 plus 1 is going to be -0.1. Okay, -0.1 times -0.25. A negative times a negative makes it a positive. 0.1 times 0.25. What's that extra decimal place going to do? Think about this. 1 times 25 is 25. You've got 1, 2 decimal places here and a third one from the 0.1. So that's going to make that 0.025 plus the 0.5 makes it
0.5.
And you guys think you have to have calculators for everything.
I mean, it would have been nice for that.
With the
I honestly
I'm
would
stretching your brains.
I would have sat there for like 10 minutes and been like, oh my god. I would
But in all honesty, did I really do any math that was horribly difficult in our brains?
No.
Yes, Doug.
would the fraction equivalent be 21/40?
Dude, what?
I honestly don't know. You'd have to check on the calculator. I don't know.
Okay.
I mean, I could sit here and think about it, but I don't want to use that time.
Because I just did it with the fraction.
Yeah. Well, now, and here's what I will say. Okay, hold on before we turn the page here. Is
Yep.
why, okay, so it doesn't tell me to do this here. Why did I do this here? I'm sure there's some reason. Because I started talking about whether this is an overestimate or an underestimate. Okay. So if we think about the graph here, just hang with me for a moment. Okay. There's my x and y axis. The original problem was what? 1 over x plus 3? Do you guys remember what the graph of 1 over x is?
Sure.
It's one of your 12.
It's the reciprocal, is it?
It's called the reciprocal graph.
Is it this one?
It's the,
No, that's
Or no, is it this one? It was like that.
Yeah, this was
wait, no. It's
that's
this. It's
exponential.
this, isn't it?
I like Doug's picture.
That's what I was doing first.
Okay, I wasn't. Okay,
We're
guys,
drawing in
cut me
the
some
air.
slack here. We're all drawing in the air, and I'm trying to catch all your drawings at once. And, okay, now. Okay, so 1 over x is this, or
Yes.
whichever way I'm supposed to be at. You guys are with me now, right?
Yeah.
You can kind of visualize this.
Yes.
Now, since it's x plus 3, that's going to take that thing and shift it 3 to the left. So now what's going to happen is basically there's a vertical asymptote 3 to the left. And I have a graph that looks like this and this.
How do you know whether it's? Oh, if it's negative. Never mind.
The negative would flip the quadrants. Is that, yeah.
Yep.
Okay, now, what we're trying to figure out is this based on where this tangent line. So this is a tangent line at x equals negative 1. Where is x equals negative 1? It's right there, yes? And I'm not sure I have my graph drawn greatly here because I have it slightly different in my notes. But here's the negative 1. A tangent line, that's not great. I ended up with the tangent line over here. But a tangent line at negative 1 would look something like that. Are you okay? Are you seeing that? Like the tangent line, when x equals negative 1, the tangent line to that curve looks something like this. This means any value on this tangent line, is it higher or lower than the actual value? Because here's the deal. We didn't plug in this negative 1.1 into the original problem. We plugged it into the tangent line, right? So my question is, the value we plugged in, it's an estimate, yes? Is it an overestimate or an underestimate of the situation? And because this tangent line runs below the graph, it's going to be an underestimate. Okay? And here's my proof, okay? If I take negative 1.1 and I plug it into the original problem, we plug it into the original problem, which was,
1 over x plus 3.
is that what, I can't even remember now. So if I plug it in to 1 over x plus 3, which is 1 over negative 1.3, this comes out to be approximately, I have written in my notes, 5.26, which I think that's even a rounded value. It's very close, yes, it's very close. But here's the deal. Our value is slightly below that. So that tangent line, because it's on the bottom side of the curve, produces an underestimate. Whereas if we had a tangent line on this curve, it would be an overestimate because that tangent line would be above the curve. Okay? That whole underestimate, overestimate is something that you will see pop up in free response questions, which is why I need to start introducing that idea. Have I kind of made my point?
Yes. You did not have me there at the beginning.
I know.
What are you talking about?
Okay? Because keep in mind, what we plugged in is we plugged into the tangent line. The tangent line is not the exact value. I probably could have done that slightly differently, but that's all right. Okay, moving on. Back page. You ready?
Like, yeah.
Let's go. Okay, you own it. Let's summarize our findings. Given, you guys saw that, and I saw your grins earlier. Okay, what is this a universal symbol for? You have to use a calculator. Okay. Given the graph of the function f of x equals 4x minus x squared, shown at right, determine how fast is the graph of y equals f of x changing at x equals 1. That is, what is the slope of the tangent line at x equals 1? Now, on part A, it asks you to use your calculator to evaluate the average rate of change, or the slope of the secant line, between the point at 1 and the point at 1.001. Be sure to show the difference quotient. Okay. Average rate of change. What's average rate of change, folks? AROC. Okay. So they're asking us to find AROC. They even define that in the parentheses that it's the slope of the secant line. Now, showing the difference quotient, okay, well, how do you find slope of the secant line? How do we find slope?
F of A plus H. Is that what you're asking?
Minus
F of A
of
H.
over H.
I don't know. Lost me.
Not exactly. You guys are giving me the slope using the
Tangent line.
Well,
So wrong.
okay, hold on here. My brain
F of B.
for difference quotient was thinking more just basic slope. I need to check my vocabulary here then. Because it does define difference quotient as f of a plus h minus f of a all over h, doesn't it? That's not where I was going here. Slope of the secant line, guys. How do we find slope?
Y minus Y1.
Yes.
Y2 minus.
Y2
Oh
minus
my gosh.
Y1
Over X2
over
minus
X2
X1.
minus
Y minus y over x minus x, right?
Yes.
Okay. Now, with that in mind, use these values here. Okay? And that means I'm going to use it as f of 1.001 minus f of 1 over 1.001 minus 1. What's f here that we're plugging into?
4x minus X squared.
Okay. Have I showed you on the calculators how you can just plug that f in once?
Yes.
I don't remember.
You have, I think, but I don't remember how to do it. I
Fair
can't
enough.
do it.
Fair enough. So if you type whatever f is into your graph, what is it, 4x minus x squared?
Yeah.
I think you guys can't see what I'm doing.
No.
Okay, so note where you're putting it. Y1, Y whatever. Mine's not Y1, but that's on me. Okay, so get that in there, and then just go to your basic screen. And as you go to your basic screen, set up your fraction bar, right? And so as I set up my fraction bar,
What is it?
now, the shortcut is if you go to alpha, is it F4?
Yeah.
Yeah.
Ah.
Pick the one you have. So like mine is in Y5. Parentheses, 1.001 in parentheses. So that's saying it's plugging 1.001 into whatever I have in Y5. Minus alpha F4 gives me my Y menu. You guys are probably using Y1 is my guess.
Yep.
This time parentheses and a 1. Over 1.001 minus 1. Ring a bell how to do that?
Yep.
Because that's something that's helpful in calculus.
I'm just taking it.
I've at least reviewed how to find it though, right?
Yeah, but I got it by fraction.
That's annoying. Whenever you delete the whole thing, and you're just like,
Yeah.
yeah, I did that.
Okay, so right there, we got to use the calculator. Happy smiles, right? And that gave us our average rate of change. Okay. Now, look at B. B asks us to find the average rate of change between 1 and 1 plus h. So realize 1 is going to be what? 1 is going to be right there, yes? And where is 1 plus h going to be? Well, 1 plus h is going to be basically the idea of right next to it. Okay, I honestly left those points a little bit farther apart than what I should have. I mean, they should be like right on top of each other. But I'm never going to get this. The idea is you're trying to find the slope. Technically, it's going to be the slope of a secant line, right? Because it's technically 2 points.
How'd you get the second point? The second point from the 1.0001?
Well,
I'm sorry, hold on. What? Yeah, that makes sense to me.
okay. So the first point is at 1, right? The second point I'm using the idea of is going to represent 1 plus h, which that could be 1.001 as well.
How do we know it's all the way there? At 3.
Well, so x equals 1 is the value I was starting with.
Oh, so we're just finding it on.
And so 1 on the graph is up at 3.
Oh, okay.
Yeah.
Is that what you're asking there? Okay. Now, average rate of change means officially we are finding the slope here. Okay. Think of this, A rock, it's the slope of the secant line. So that means y minus y over x minus x. I'm debating how I want to write this. So you can think of this as f of 1 plus h minus f of 1 over 1 plus h minus 1. So we're using that same idea of finding slope that we used earlier, yes? It's just that I can't plug this one into the calculator, can I? Sadly, no. I'm with you, trust me. So, let's do some math. F of 1 plus h. What's that going to mean?
Four times quantity 1 plus h minus 1 plus h.
What? He's pulling from the
I'm
X
going
cube.
to have that.
F of 1 plus h, every place I see n, x, we're replacing it with 1 plus h. So 4 times x minus x squared. Okay, now minus, I still have to do f of 1, don't I? Every place I see an x, I'm replacing it with 1. Now, do I want to put parentheses? I'm going to put parentheses here. Minus the quantity of whatever 4 times 1 minus 1 squared is. All over 1 plus h minus 1. Notice I put that second piece in parentheses because we're subtracting that whole value. Okay. We need to do some algebra, yes?
Yes.
Okay, 4 times 1 plus h.
Plus 4h.
Okay, we're all there, yes?
Oh no.
Now, we're going to subtract, and we're going to be doing 1 plus h quantity squared. So, foiling, yep. 1 times 1, 1. But I'm going to subtract, so I'm going to say minus 1.
Okay.
Outsides?
Minus 2.
Outsides are going to be
H.
1h. Insides are going to be
H.
1h. 1h and 1h is 2h. But I'm subtracting, so I'm going to say minus 2h. Last,
Minus h squared.
h times h is h squared, so minus h squared. And then this value, 4 times 1 minus 1 squared,
3.
so minus 3. All over?
1 plus h plus 1. Minus 1.
Just H.
Yeah, absolutely.
I need to remember
Yeah.
Can I just go ahead and say h at this point?
I need to remember that PEMDAS is a thing.
PEMDAS is a thing. I don't even want to know, but yes, PEMDAS is a thing. Okay, anything cool happen here, I hope?
Yeah. You're left with 2h minus h
4H
squared.
minus 2H is 2H.
4h minus 2h is like terms. What other like terms do you have?
4, 1, and 3.
4, 1, and 3.
4 minus 1 minus 3,
0.
0.
2H minus H squared.
So
2h minus h squared over h.
Oh, yeah.
4h minus 2h is 2h minus h squared all over h. Officially, I'm going to factor that h out on top, right?
Mm-hmm.
H times
2 minus h.
2 minus h all over h.
H is canceled, just 2 minus h.
H is cancel. And our slope is 2 minus h, or our A rock here.
Don't ever say that. You feel like so filled.
It just seems so perfect.
Okay. Now, A rock is 2 minus h. I will say, and this little caveat is in my notes, 2 minus h as long as h does not equal 0. Because where was h? Before we cancel it out, it was in the denominator. It doesn't matter that it canceled out. It was in the denominator at one point. So h could not be 0. Because that would make this cease to exist. Okay, so you see those little caveats at time. Just beware. Okay? Okay. Somewhat there?
Yeah.
Okay, C. You ready for C? It's a small box. That means it's got to be a smaller answer, right?
No,
In theory.
It is.
but never hard.
What happens to the secant lines between the points 1 and 1 plus h as h goes to 0?
It does not exist. Or there is.
Smaller, smaller, smaller. Till it does not exist.
Yeah.
Well, if we're talking about as h goes to 0, could we find the limit as h approaches 0? Okay. And so when we're talking about what happens to the secant lines between those 2 points, then we are looking at the slope there. Okay. So we're going to be doing the limit as h approaches 0 of, is it 2 minus h? How do we do that limit?
2 minus 0.
No.
Yeah.
If I'm just doing the limit as h approaches 0, I've already done all that simplifying on the last one, right? The limit as h approaches 0, plug 0 in, and we end up with 2 minus 0, which is 2.
So as the limit gets
2 minus
closer
1.
to 0, it just equals 2.
Yep. Or what we're saying is, in this case, as the slope, as h approaches 0 is as you're basically putting no distance between 1 and 1 plus h. So, you know these 2 little points here?
Yep.
As h approaches 0, so basically as h ceases to exist, these 2 points are going to get closer and closer together. And at that point, we're talking about, okay, what's the slope of this line at 1? Well, that slope is going to be 2, which matches up. That was between 2 very, very close points that we found the slope to be 1.999, right?
Mm-hmm.
Or another 9 if I didn't say it. I don't know. Okay, so this is us looking at the limit here. Okay, the limit as h approaches 0. So as those 2 points are becoming 1, basically, that limit is going to become 2, or the slope is going to become 2. Okay, that's what that one was saying. Okay. Find a general formula for finding the slope of the tangent line at any point by using the points x and x plus h. So this is going to be going back to using our limit formula. Basically, we're practicing finding a derivative that we're going to be doing. So this is going to be slope of the tangent line. This is going to be the f of x plus h minus f of x all over h. Gosh darn it. What did I forget to write in front of it again? Do better than me. I know. It's hard when the teacher is continually messing it up to do better, but please strive to do better than me. Okay, so that's the general formula we're going to be using, guys. Sorry. Limit as h approaches 0 is f of x plus h minus f of x all over h. And what is f of x for the terms of this problem? Go up high. What is f of x?
Oh, 4x minus x squared.
Yep. And that was just part of the original definition, right? 4x minus x squared. Okay, here we go. The limit as h approaches 0. F of x plus h. Using f of x, yes?
4
times x plus h minus x plus h minus.
There's f of x plus h, right? 4 times the quantity x plus h minus x plus h quantity squared. Minus f of x. What's f of x?
4x minus x squared.
And I'm going to put this in parentheses. It's minus the quantity 4x minus x squared. All over
h.
How do you know if it's going to be a quantity if it's not the quantity?
It's always the quantity when you're plugging something in. If we're just adding it, though, it wouldn't matter. Because I'm subtracting, that subtraction has to apply to whatever it is, even if it's not there yet.
Oh,
Okay? Okay. Now, we did this with 1 plus h earlier, didn't we? So now we have to do it with x plus h. Okay. So let's do some algebra. 4 times x plus h.
4x plus 4h.
Okay. Minus x plus h quantity squared. So FOIL and subtract.
minus x squared minus 2xh minus h squared.
I can go with that. You guys, you got the minus x squared, yes? Then your outsides, you've got xh. Your insides, you've got xh. So that is 2xh, but we're going to say minus 2xh and minus the h squared. I'm going to go ahead and distribute this minus. It's minus 4x and plus x squared all over h. Some cool things should be happening here, right?
4x cancels.
And x squared.
Basically, you should have all h terms left on top. Limit as h approaches 0 of, nothing cleans up, does it? No. 4h minus 2xh minus h squared all over h.
Distribute, not distribute. Factor out that h.
Okay. Factor out what should be an h on top. Then I have h times 4 minus 2x minus h all over h.
It just canceled.
The whole design of that is that an h will cancel right there, yes? If an h doesn't cancel there, if not everything has h's on top, I would go back and check your algebra. You made a careless mistake, most likely. So the limit as h approaches 0 of 4 minus 2x minus h
h equals 4
How do we do a limit? If it's as h approaches 0, every place you see an h, plus it, plug in a 0, and then we're left with
4 minus 2x.
4 minus 2x. And that is our slope of the tangent line. Okay? That's your general formula for finding slope of the tangent line at any point on that curve.
All that.
Or basically you just found a derivative. There's a much easier way to find derivatives when we get there. We're just not there yet. Okay. You have some homework to look at. Okay.
I don't wanna look at it.
I know I have not posted the answer keys. I can almost guarantee it.
20%